Okay, good morning. And so we continue the lesson. If you remember, we started talking about primitive functions. Today I will present more examples. So it is important. They are important examples. Of course, I go a little bit beyond the functions expressed in the book, but I think all of them are necessary. Okay, now we actually start with the first example for today. So you are supposed to determine the, and if you see I have written it in italic because I told you there are articles a, o, and the, yes? When it comes to determining primitive functions. When I say all, I'm just giving you this message that I want you to write this capital C that is usually there. And if I say you can choose whatever you want to for C, which is simplest possible choice is C equal to 0. And if I say there, I have to provide you with an extra piece of information, but last session I didn't give an example of that type. So let me now start solving this problem today here together, okay? So let us read the problem. Determine the primitive function capital F of this function little f expressed here, but such that I have an extra condition to satisfy. F of e is the Euler number, is supposed to be 2. So the formulas that you need here, so let me write them here in front of you. So do you remember one formula that is relevant to this problem is that what is a primitive function of x to the power of a if a is not equal to minus 1? Yes, hopefully you remember this, even though this is given in the formula sheet. So primitive function of that function is what? 1 over a plus 1, and then I have x to the power of a plus 1 plus an arbitrary constant c. Another formula is that if I give you, do you remember what happens if this a is equal to minus 1? If x is equal to minus 1, then this becomes x to power minus 1, which is just 1 over x. And we also answered what will happen if my function is 1 over x. Do you remember what's the answer? So the previous problem, the previous formula is the formula from Math 3C, but 1 over x we learned this year. What is the, yeah?
Was it ln of x?
ln of x, and of course there was a limitation. Do you remember? Absolute value, or in the book they are emphasizing that x is equal to a positive number. So let me put this in a box. So this is somehow you can consider that this is the formula sheet you have, and then we want to use this to solve this problem. So what we should do, I start with, let me change the color here. So, okay, so what I do, I would say that capital F of x is supposed to be a primitive function of this part minus a primitive function for that part. So for the first one, I have a 4, but for x to power 3, I use this formula by giving the role of 4 to minus to a, sorry, by giving the role of 3 to a. So the answer becomes 1 over a plus 1, which is again 4, x to the power of 4. But how should I interpret 3 over x? 3 over x is another name of 3 times 1 over x. 3 is just a multiplicative constant, so I need to have a primitive function for 1 over x, which is ln of x. So what's the answer? So it is just minus 3 ln of x. And here, momentarily, you put the constant c here at the end. Let me simplify this a little bit. So f of x becomes equal to, so this 4 and that 4 are cancelled. This becomes x to the power of 4 minus 3 ln of x plus c. I am not worried about to put absolute value here because the value given for me is e and e is positive. So I'm really on the safe side here. So this is the answer to the problem of determining all primitive functions. but they have asked to determine their primitive function, and they have provided me an extra piece of information. So how can I exploit that? I would say that, okay, now you are telling me f of e is equal to what? Is equal to 2. What does this mean? It means that if I go to my primitive function capital F and replace every x with e, the answer is supposed to be 2, yes? So what does it mean? I go to my function, I replace every x with e, and the answer is supposed to be 2. So using this equation, I can find my c. So let me simplify. What is ln of e, by the way? It's 1. So it is just simply e to the power of 4 minus 3 plus capital C is equal to 2. I am finding c. So I isolate c on the left by moving other terms to the right. Minus 3 goes to the right, it becomes positive 3, so it becomes positive 5. And then I have minus e to the power of 4. But what I expect you to write as the answer is the whole answer. So you need to write capital F of x is equal to, you just copy and paste this part, but instead of capital C, you put this number in. Yes? So then it becomes x to the power of 4 minus 3 ln of x, and then I have plus 5 minus e to the 4th. Yes? So here the point is how to treat this article de here. Is that clear? Okay, so that's one thing. Okay, but mainly I want to improve our skills in finding primitive functions. I don't know how many of these examples we're supposed to solve, but I think the main problem here is to using again these two formulas. Yes? So I will not actually rewrite the formula there. It will take I hope that you remember it, yes? X to power a, if a is not equal to minus 1 follows this rule. If x is positive for 1 over x, I have this rule. Okay, so now I want to start the problems one by one. Okay, so number 1, I want to find a primitive function for this one. This function is not directly one of those functions that we have. We are supposed to do what? To change the form of the function in a way that we can use that. Okay, hopefully you can do that, yes? So what I can write? I can write that the little f of x is equal to 2 over. What can I write for the third root of x? X to the power of 1 over 3. And then I bring it up, and then this becomes negative 1 over 3. And then immediately, I hope that you agree with me, I can calculate capital F of x using the formula that we had. So 2 is a multiplicative constant. I just write it there. And the answer is 1 over a, which is minus 1 over 3, in this case, 1 unit more, x to the power of minus 1 over 3 plus 1 unit more. And then look at the article all here. So this is sending you this message that you have to write capital C. So, okay, so we have to write the capital C. And usually I prefer to simplify a little bit. So this one is just 2/3. This 2 and that 2 are cancelled. This 3 goes up. So it becomes 3. And this is again 2/3. Yes? So I would say that, okay, it is 3x to the power of 2/3 plus the capital C. Yes? Is that understandable? So what is the point of this exercise? I just want you to, let me just remind you, do you remember we did a lot of guesswork to find those formulas? But there is no way for us to guess these things afterwards, so we are doing it systematically. Okay, so let me also solve the next problem, part 2. So how should I solve part 2? What is your opinion? So we are supposed to solve part 2. We want a function whose derivative is this one, and I hope that you agree this is not easy to guess anymore. Yes?
So we could just separate these.
Yeah, exactly, separating them. So I will do that for you. So f of x is equal to, I separate them as x to the fourth divided by x to the power of 3 plus 5x divided by x to the power of 3 plus 1 over x to the power of 3. And then simplify this a little bit. So here I am left with 1x in the numerator. Here this x and this x are gone. X squared is left in the denominator, but I'm supposed to bring it up, so it becomes 5x to the power of minus 2. And then the other one, I bring x to the 3 up, it becomes x to the power of minus 3. And now everything is ready, so I start finding my primitive functions. So for the first one, what is the answer? Can you do it in your head? What is x? A primitive function for x is?
1 over 2x squared.
1 over 2x squared. A primitive function for the other one, I have 5. And then I have 1 over minus 2 plus 1 x to the power of minus 2 plus 1. And plus, for the next one, I will have 1 over minus 3 plus 1 x to the power of minus 3 plus 1. I really recommend you to do these calculations in your head as much as possible. Then I have to put this overall constant. So finally, the capital F of x is equal to 1 over 2x squared. And then you see what's happening here. Minus 2 plus 1 is just minus 1. 1 divided by minus 1 is minus 1. So this becomes minus 5. And then I have x to the power of minus 1. And then plus a minus 1 over 2x to the power of minus 2 plus a constant c. Yes? I hope that this is understandable. So this is just minus 2. That's also minus 2. So I put them here. So that's my function. Yes, is that clear? Yes?
Yeah, so just a side question about the plus c. Is it just a convention to do plus c? Or is there no difference between plus c or minus c?
No, there's no difference. Yeah.
So
In principle, you should have one constant for the first function, another constant for the second function,
Okay.
but you can combine all those constants into one constant and name it something.
Okay, so it's just a convention to type plus c.
Yeah.
Okay.
Okay, so what about number 3? What about number 3?
You can start by bringing it up.
The whole thing, you mean?
Yes.
Whole thing also works, but what do you think I will do with that 2 there? I prefer not to bring 2 up, yes? So I would prefer to do it like this. So let us write it. So first, I would write it as 1 over 16x to the 4th.
Okay.
And then I interpret it as 1 over 16 multiplied by 1 over x4.
Yeah.
Then, yeah, of course you can do it in one go, but I want you to understand, because whenever I saw, by the way, in the exam, people bring everything up. If you bring 16 up, that's not wrong, but you should also put minus 1 there. Yes? Okay, so that's the correct thing. And then I can calculate my primitive function. So let us do this in our head as much as possible. So 1 over 16 is just it. What about x to the power of minus 4?
1 over minus 3.
Yes, 1 over minus 3 means 1 minus 1 over 3. They are the same. X to the power of minus 3. And then I have a constant. So finally, I have f of x equals to what? Minus 1 over 48. If you want to, I can bring this back. It doesn't matter, okay? But I will bring it back, and then I have a constant here. So that is the function. Okay. So it might be it's a good idea if you think about these problems yourself now. I give you a little bit of time so that you can, of course, might be algebra is a little bit involved and boring, but I want you to be able to do it. And then we go to the next problem. So I wait for you to work on 4 and 5 yourself first. In 4, you see that I have just changed the name of variable from x to t. That's also common, so you need to be able to work with different names of variables. Okay, so what about the first one? I don't think it is hard. So you know that the idea is again to separate them, but you also need to use the formula for square root of 3 as exponent, yes? So what we do, we just say that, okay, f of t is equal to 2t squared divided by square root of t, but instead of square root of t, I write t to the power of 1/2. The next one is 4. I have t to the power of minus 1/2 on the top, and then I have t to the power of 1/2 again because of 1 square root of 2. And then I have the same story here. So this is t to the power of 1/2. Then I simplify this a little bit. So what can you do it in your head? So there is a 2 here. What is the answer? The exponent up is 2, the exponent down is 1/2. If I subtract them, it becomes 3 over 2. And then what is the next one? It's 4. What?
T to the minus 1.
T to the minus 1. Okay, so I intentionally design it in that way. And then for the next one, it becomes t to the power of minus 1/2.
Yes.
But you realize that this is exactly that exception, that I have a power of minus 1. So then I have to bring it down again, yes? That's good. If you understand that, you're on the safe side. So what we do, it's 2t to the power of 3 over 2 plus 4 over t. If you can anticipate this, you don't really need to do it in two times. So you can just do it in one go. Anyway, now everything is ready. I just start finding my primitive function. Let me call it capital F, but because my variable is t, I just call it f of t. Okay, and then I have 2. Can you do that one in your head? 3 over 2 plus 1? 5 over 2. But it appears in the denominator. So when you bring it up, it becomes 2 over 5. Yes? So it becomes 2 over 5, but t to the power of 5 over 2. Yes? So the formula is 1 over a plus 1, x to the power of a plus 1. A is 3 over 2, so it becomes 3 over 2 plus 1, x to the power of t to the power of 3 over 2 plus 1. But 3 over 2 plus 1 is 5 over 2. 5 over 2, 1 over 5 over 2, it becomes 2 over 5. Yes. So try to do these things in your head. And what is the answer to the next part?
4 ln absolute value.
Yes. So it becomes 4 ln. Let us follow your book, but the correct one is real. Let me put absolute value too. Okay, that's the correct one. And then what happens for the next one in your head again? I have minus 1/2, I add 1 to it, it becomes?
Positive.
It's positive 1/2, but it is in the denominator, so it becomes 2. And then you have t to the power of 1/2 plus a constant. So, okay, so you can finally write your answer in a little bit simplified version. So it becomes 4 over 5 t to the power of 5 over 2. And then I have 4 ln of absolute value t. And then if you want to, you can write the last one in the more familiar form of a square root of t. And by the way, I hope that you agree that there is no way that we can guess this is the function. If you don't believe that, you should type it in GeoGebra, ask GeoGebra to differentiate it, and you see that the answer will be this function. Okay, but it was not easy to guess this function. And I think you know already what to do with number 5, yes? So this was number 4, now this is number 5. So what should I do in number 5? Is it clear? For finding a primitive function for number 5.
You just multiply.
Multiply and then use the same idea, yes? That's so I multiply, so this is my common, this is the fraction line, so this becomes x to the 4th minus 2x squared plus x squared minus 2. And we know that what we are supposed to do at the very end is to write everything in terms of exponents. So let me just do it right away. So instead of a third root of x squared, can I write what? What can I write? 2/3 or 3 over 2? Which one is that, do you remember? So if I have the mth root of a to the n, what can I write it? It becomes a
N over M.
n over m, yes. So here, what should I write? So I write 2 over 3. And then before separating them, I can simplify these two terms into minus x squared. So let me just do that first. X to the 4th minus x squared minus 2 divided by x to the power of 2/3. Okay, now you know that the, 2 over 3. 2 over 3. So now you know that what is the point? The point is to separate again these by these together, and then these together, and then these together. So let us do it in our head as much as we can. Can you do it in your head? X to the 4th divided by x to the power of 2/3. So what's the answer? X to the power of what? 4 minus 2/3. Yes? Which is?
14 over 3.
No,
10 over 3.
10 over 3. Yes, minus. What about the next one? X to the power of 2 divided by 2x to the power of 2/3. It is how much? 4 over 3. So x to the power of 4 over 3. And then what I'm supposed to do for the next one? I just bring it up. Yes? So you see, so far I haven't started even primitive function calculating that. I'm just simplifying my function in a way that I can use the formulas. Okay, but now let us do again in our head. Let us see. Yeah. Okay, so can you do the first one in your head? X to the power of 10 over 3.
13 over 3.
13 over 3 in the denominator. So it is 3 over 13. But the other one becomes, of course, 13 over 3. That's correct. The other one, do it in your head.
3 over 7.
Yes, so it is 7 over 3. So it is in the denominator 3 over 7, but x to the power of 7 over 3. And then the next one, finally, in your head.
Is it 6 over 4?
No. Yes, what's the answer? So minus 2 over 3 plus 1. It is 1 over 3. But it is in the denominator, so it becomes 3. And there is a 2 there, it becomes 6. Minus 6, x to the power of 1/3. And then I have a constant. Yes? Is that clear? So this is the something, so you see that this is just, to be honest, this is except the one that contains ln, everything is matrix C.
Yeah.
Yes? So it is not a very complicated formula. Okay, now let us go and talk a little bit about exponential functions. I gave you the formulas last time, but we didn't have time to give an example. So let me just review the formulas here. What are the formulas, do you remember? If I have e to power some constant kx, what is a primitive function for that? 1 over k, exactly, e to power kx plus the famous constant c. But we also had something for a to power kx, if of course a is positive. So it was a little bit more complicated. So I have of course 1 over k. I have the function repeating itself, but there was something more here, and that was ln of a. Yes, of course, don't worry about if you forget the formulas, they will be given to you. Okay, so these are the formulas that I am going to use here for this problem. Okay, so it's very simple. Let me just start right away for number 1. So what is capital F of x? Okay, a primitive function for this one will follow this rule, but k in this problem is 3, so it becomes 1/3 e to the power of 3x. What is your opinion about the next one? It's minus 2e to the power of minus 2x. Do the calculations in your head. Plus, yes, because it goes minus a half down. That minus a half cancel that minus 2, it becomes positive e to the power of minus 2x. And then what about x? What's the answer? 1 over 2x squared. And what about minus 1? Minus x. And then again, it's emphasized all, so it means that you have to respect that and write constant C there. Okay, so very simple. So number 2. So I intentionally I wrote it in a little bit, by the way, it's very beautiful, isn't it? X to power pi, pi to power x, yes?
Very.
So we want to find a primitive function for this one. Okay, so let us see how many of you will make a mistake there. So which one of these formulas is suitable for the first part?
The second one.
Okay, which one? Which one of these formulas is suitable for the first part?
Neither.
Neither.
Uh,
Yes? Because this is x to power pi, yes? These are exponential functions. What is the difference between x to power pi and pi to power x? Here it's a polynomial, it's a power function,
Yeah.
because the exponent is constant, the base is variable. Here it is an exponential function because the exponent is variable, the base is constant. Now these formulas are formulas for exponential functions, okay? So we are not allowed to use these formulas for that one, but is it a very strange thing? No, because that's the previous problem, yes? So what's the answer finally? Tell me. So f of x is equal to what?
1 over pi plus 1.
Yes, 1 over pi plus 1, x to the power of pi plus 1. But for the second one, I can use one of these formulas here. Which one? The second one. I give the role of a to this pi here, yes? So this becomes what? Pi to the power of x, but I have to divide by what? ln of pi. And then of course I put a constant here. That's the answer. Okay. And what is your opinion about the last one finally?
We start with multiplying.
Yes, because do you remember I told you that there is no counterpart for the product rule or the quotient rule when it comes to primitive functions. You have to really multiply them. There is no other way. Okay, so what we do, we just do that. First of all, I simplify my function by expanding it. So e to power 2x, and then I use the squaring rule to raise this to power 2. The first one squared, which is 8x, 2 times the first one times the second one, and then plus the second one squared, and then I copy and paste the rest. Still it is not finished. I multiply this factor here inside these 3. So this becomes e to power, what should I write? E to power 2x, yes, it is 10x. And then I have 2 e to power 4x plus e to power 2x minus 2x minus 1. Now everything is ready, so I calculate my primitive function, capital F of x. Okay, just tell me what's the answer. The first part becomes 1 over, thank you very much for cooperation, and then 10x. What about the next one? Yes? So you don't want to cooperate, okay, so let me just write myself. So it's 1 over, so then I will not explain, okay?
1 over 2.
Yes? Yes, is that understandable? That's up to you. If you don't understand, that's your problem now, because you don't want to cooperate, yes? Yes?
So, because you said there's no equivalent of counterpart of the chain rule or product rule?
No, I
So
didn't say about chain rule. Product rule and quotient rule.
Product rule and quotient. So there is some sort of chain.
Some sort of the chain rule. It's called substitution method.
Okay, will we learn about that?
No, not in high school.
Okay. But there's no product rule or quotient rule?
No, the product rule can be modified to something which is called integration by parts.
Okay.
But no, there is no direct rule for those things.
So there is some sort of method in case some problem like that appears which you couldn't solve normally. There are some.
No, there are some very specific functions that you can apply those kinds of tricks to them.
Okay.
But this is not
But
like
it's not
derivative.
It's not as general as the derivative.
No.
Okay. So it's more complicated.
Yes.
Okay.
So is that clear now?
Yes.
Okay, so this exercise I want you to learn because every now and then, for example, this one, it is in the book, okay? And if you don't know the trick, you will not be able to do that. For these ones, yeah, you just need to write the formula down. But intentionally, I wrote some problems here for you so that you learn how to apply these tricks for these kinds of functions. But for the time being, you remember these are trigonometric sine and cosine functions. Again, as before, let me review the formula. So what are the relevant formulas here? Do you remember? If I want if I have sine kx, if I ask you what are the primitive functions for this, what is the answer? Do you remember? It starts with a negative 1 over k, and then I have cosine kx, and then of course this constant c. And if I have cosine kx, a primitive function is just positive 1 over k sine kx, and then plus a constant. So these are the formulas that in principle we need for primitive functions of sine and cosine, but it will not be enough, as you will see a little bit later. So let us try talk about them. I hope that I have put the space here, yes. So what should we do? Number one, I think number one is a very standard E-level problem. So I want to find all primitive functions again. Okay, so here, f of x is equal, okay, can you just do it in, okay, let me just do it myself here. So it's minus 2, it's a constant, so I don't care about that. But for solving that part, I have to use the second formula, giving the role of this k that you see here to number 3. So the answer is what? Times 1 over 3 sine 3x, yes? And then I have plus 4. Now for this one, I use this formula, and I give the role of k to 2, so it becomes 1 over 2, yes? Oh, sorry, minus 1 over 2, and then cosine 2x.
Oh, but
And then I have a constant. Yes, please.
for the first number, minus 2, why isn't it 1 over minus 2?
No, it's minus 2 is a constant. K is the number that appears inside. Yes?
Okay.
Okay, and then if you want to simplify this a little bit, so this becomes minus 2/3 sine 3x minus 2 cosine 2x, and then I have a constant c. That's the answer. This is E-level question, yes?
Is it possible to take the primitive function?
Yes, why not? But it is, no, I don't do that. Because you do it once more, what's the problem? But that is not, by the way, it is not like the derivative. In derivative, you can do it indefinitely. But if you take a primitive function, it becomes a new function. There is no guarantee that we can find a primitive function for that if it is so complicated. So even not complicated. Last time, if you remember, I told you that there is no primitive function for such simple function in terms of elementary functions that we know. We can artifact a new function, will play the role of a primitive function for that. Yes? Okay, but what is your opinion about number 2? What do you think I will do?
You will multiply.
Okay, but instead of multiplying, I use the squaring rule, yes? So I raise it to power 2. And then, of course, it becomes extremely simple, but not that much. Okay, so I want to hear from you again. So f of x is the first one squared, 2 times the first one times the second one, and then plus the second one squared. Okay, but I hope that you immediately recognize this pattern. Yes, which is 1. But what is your opinion about this one? Yes, at sine 2x. If you don't distinguish it, there is no way for you to solve it. So you have to remember that 2 sine x cosine is something. Yes?
Sine squared x.
No. He mentioned it is sine 2x. It's a double angle formula. Yes? So let me write the formula here. If you remember sine 2 theta, we learned in chapter 2, it is 2 sine theta cosine theta. So when it comes to primitive functions of trigonometric functions, you need to also be ready to actively use the formulas in trigonometry as well. Yes? So sine squared plus cosine squared is, as you said, 1. And then I would write it as sine 2x. Okay, now I want to hear from you. So what is a primitive function? I have to find a primitive function for 1, which is famous. What's that? It's just x. And then the other one, sine 2x, I use this formula and giving the role of k to 2, so it's minus 1 over 2 cosine 2x, and then I have a constant c over it. Yes?
But isn't the derivative of sine squared of x to sine x cosine x? Can you skip that and go directly to say that?
No, you are right. If you write that one, I will give you also the points. But if I want to go to that, the problem becomes complicated. So let us ignore that. Yes, but you are right. Sine to the power of 2x, its derivative is exactly 2 sine x cosine x. Yes, thank you. Thank you. Okay, so number 3. So what is your opinion about number 3? Yes? F of x is equal to, and then the first one again is squared. Hopefully you remember what I'm going to do, but still there is some trick there. I want you to solve it for me. So the first one squared minus 2 times the first one times the second one, and then plus the second one squared. Yes? Okay, it seems a little bit hard, but do you know what to do now? Yes?
It's still sine squared of...
Yeah, it is sine squared of something plus cosine squared of the same thing.
Yeah.
So I do not have any problems with that. Okay, so that's still 1. But how can I do this one now a little bit better?
That's just sine of 2 times
That angle, which is?
2 times 3x over 4.
Which is?
over
3 over 2x, yes? And then instead of writing it, so let me just do that exactly. So what I will do, I will write again 1 minus sine of the double angle. So I multiply this angle by 2, it becomes 3x over 2. But I interpret it in my head as 3 over 2 times x because I want to give the role of k to this guy. Yes? So this is preferable to write it as 3 over 2 x in front. Yes? And now everything is ready. Finding a primitive function for x for 1 is extremely simple. It is what? Just x. And then I hope that you see, if I compare this with the first formula, this is playing the role of k in this problem. And I want to have minus 1 over k. This is k, 1 over k becomes 2/3, yes? And then I have a minus sign there, so it becomes positive 2/3, and cosine 3 over 2 x, and then of course I have a constant. Yes? So that is important to interpret these fractions of numbers as multiplicative constants. Okay, any questions so far?
Can you take a primitive function
Of a primitive function?
No.
Yes, we can. Yes.
Of an equation. If you have
A primitive function of what?
of an equation, if you have an equal sign and then 2
No,
functions, is it positive?
no. Unless you put a constant there. So that's what I told you last time. If the functions are equal, there is no guarantee that primitive functions are equal. But the primitive functions differ at most by an additive constant. So if f prime is equal to g prime, I cannot conclude that f is equal to g, but I can conclude that f is equal to g plus a constant. Okay. So now this problem, I have seen it in your book. We want to solve it. So we want to find a function whose derivative is sine squared x. So let me go to the other page. So this function is easy to remember. So the function is f of x equals to sine squared x. So what do you think I will do here? Yes?
we can rewrite sine squared of x as, because we know sine squared of x plus cosine squared of x is 1. So sine squared of x is 1 minus cosine squared of x.
But then the problem is that what is a primitive function for cosine x squared?
Tangent of x.
But no, 1 over cosine x squared is tangent. Don't get confused. So I understand what you are saying now. So a primitive function of 1 over cosine x squared, you are right, it becomes tangent.
Okay.
But if you do that trick, still cosine squared is in the upstairs, yes? So you cannot use that trick. Okay, if this trick does not work, do you remember any kind of trick that will help us to solve that problem?
Chain rule?
No, chain rule there is no, you don't have it here. No, it's trigonometric formulas, yes?
You take it as 2 sine x. Like it's 2 times. So sine x, then sine x again. And then
Okay, but then there is no way, be careful. Still you don't believe in me, okay? So yes, you are right, I can write it sine x times sine x, then what?
And then you take the primitive function.
Of this one and multiplied by this one. It doesn't matter how many times I say there is no such a rule, but still you insist to use it. Okay, that be my guess, use it. So you cannot say that I take the primitive function for this one, which is minus cosine, and then this is minus cosine, and multiply them. There is no such a rule. Yes? Okay. And by the way, that's not what I'm saying. You can do that and then differentiate. You will see that you will not end up with the answer. So this means that this method is not working, okay? Not because just I am telling you, just believe in me, yes?
We go to jail if we break the rule, right?
No, here.
Yeah, that's I remember you said it.
So I'm a really liberal man. So you can just do whatever you want to do, even in math, you know.
So you've changed. Oh, we can do whatever we want, but we'll get F.
Yes, that's a that's a rule. And even by the way, I really don't care about that rule that much. But yes, let us. Okay. But the formula this is something that you need to remember. So for example, the first time I saw my problem, I don't remember if I could solve it or not, but then I realized that this is a trick that I have to have in my head. Otherwise, I will lose that point, yes? So the point is that, do you remember a double angle formula for cosine? We had 3 formulas for the double angle of cosine. One of them was involved with sine squared, yes? So do you remember? The formula, so do you remember, if I write, let me just review a little bit. If I write this one, what is the answer to this one? Is sine squared. But there is another way, which is not useful here. Because of course you can write this, a primitive function for this is simply x, but the problem is that what's the primitive function of cosine x squared? That's the same level of difficulty. Okay, so this formula is not helpful, so let me get rid of it. So another formula, let me just remind you, we had a formula for the cosine of the double angle formula, which was expressed in sine. Yes, it is an interesting formula. You know, if you have just 1 minus sine squared, the answer becomes cosine 2 is up there. But for some very nice, strange thing, if you put 2 here, then 2 goes down. So I usually remember them together. This is the fundamental theorem, which is very simple, but this is a little bit more advanced. We'll learn about that later. Yes? So I want to use this formula. So how can I use this formula? Then let us manipulate it a little bit. I move this to the other side, and I move this to the other side. So this becomes what? 2 sine squared theta is 1 minus cosine 2 theta, yes? And then because I am looking for sine theta squared, I divide everything by 2, so it becomes 1/2 minus 1/2 cosine 2 theta. So this is one formula here. So we can use it, yes? Now hopefully you see why the problem is solved. Because 2 is not any longer in the power. It's actually have gone down, so I can use that formula. So let me just rewrite this again. So f of x is equal to 1/2 minus 1/2 cosine 2x. Okay, now I ask you, what is a primitive function for this? A primitive function for 1/2 is 1/2 x. Okay, can you do this part in your head? Because now 2 is exactly playing the role of my k. So what's the answer? Minus 1/2 is already there. 1/k also goes out, which in this case is 1/2. 1/2 times 1/2. And then I have sine 2x. And then I have a plus a constant. So that is the correct one. So that's the trick. So remember, if you have the second power of sine, you need to remember how to use the double angle formula. Yes?
Were these in the formula sheet?
The double angle formulas in this form, yes.
Okay.
But then you have to do it yourself to
Yeah,
extract
because I
them.
remember it also said cosine squared minus sine squared is the same.
Yes, and there's another one, which is 2 cosine squared theta minus 1. Yes? Okay, so if you learned what I said, I want to wait for you to do the next one yourself. Number 5. Okay, do you have any suggestions? Yes, Hussein?
It offers 3x.
No, just tell me what to do. I don't know the answer.
You take the second formula I use,
Okay.
2 sine, and then I convert it so it says 3 sine squared. I did it by dividing by 2.
Okay, but what do you do for cosine squared? Because yes, you can use the same trick for the first part, I agree. But what do you do for the second one, yes?
You can rewrite cosine squared x as 1 minus sine squared x, and then you have sine squared x. You can just use the formula here.
Yes. So this is working, but I prefer it a different way. Yes? Because you know why we should bother with two formulas. I would say that let us just do it like this, you know. Because in the previous case, I learned about sine squared. So let me use my knowledge here. So I would just write 3 sine squared x. And then I use just the normal, very simple 1 minus sinus. Yes? Yes? I'm just using the very fundamental, I mean, what is it called in Swedish? So sine squared x plus cosine. Yeah, ettan or something like that. So this is, I use that one. But why this is useful? Because I already solved that problem. So I multiply this 4 in, so it is 4. And then I have minus 4 sine squared, and there is a positive 3 sine squared, so it becomes minus sine squared. Yes? And of course, in exam, you don't have access to what I have done in the previous case, so you have to do it yourself. But now I can cheat a little bit and then find a primitive function, because primitive function of 4 is just simply 4x, and a primitive function for sine squared is just this expression that I got before. But there is a minus sign here, so this becomes minus a half x plus 1 over 4 sine 2x. In principle, you can write minus c, but it doesn't matter. You can write plus c. And these two are similar, so let me combine them. It is 7 over 2x plus 1 over 4 sine 2x, and then you have a c here.
Baba,
Yes?
can you do the lengthy way also?
What?
Can you do the lengthy way?
No, the lengthy way is you have a similar formula for, so let me write it
So
here.
3 sine squared x. I want to see if I
No, the lengthy way I do it like this. I mean, you have one formula that I expressed here, but then there is another formula in the formula sheet that this is cosine 2 theta is equal to 2 cosine 2 theta minus 1, yes? And then I move 1 to the other side and then divide by 2, yes? So this means that cosine 2 theta is equal to 1/2 plus 1/2 cosine 2 theta. So that is the formula which will be useful if you want to do it in a longer way, yes? By the way, it's important to know both of them. And the formula is very nice, because sine squared and cosine squared are related to the same combination, one of them with negative sign, one of them with positive sign. Yes? Okay, that's it. We go to the next one. The reason that I brought this up, because I saw it in the book. It's a level 3 problem. I think the last one, for example. So if this is, I want you to learn, there is no way for you to solve this if you don't know the trick. And the trick is this. So let me just review a little bit. Do you remember if I have ln of u and I ask you to differentiate it, what's the answer if u is a function of x? What is that? Do you remember? U prime over u. Okay? So now let me ask you, if I ask you what is a primitive function of u prime over u is what? ln of u. Okay? So this is the trick in all these problems, yes? Okay, so whenever you see this combination, remember this trick. If you see a fraction so that the numerator is the derivative of the denominator, you need to remember this trick. A primitive function for this one becomes just simply ln of u. Okay? So let me start from number 1, which is not in the book, but that's the same spirit, okay? So number 1, do you see that this is happening here? Do you see it or not?
Yes.
It is 2x, and it is x squared plus 1. Okay, let me review. It's a fraction. The numerator is the derivative of the denominator. So what you can do, you can give the role of u to this guy, then what this will be? This becomes u prime. And now if I ask you what is a primitive function for this, what is all primitive functions for that, what's the answer? It's ln of
X squared plus 1.
It's ln of u, which in this case is
X squared
plus 1, but because I have asked for all, I don't know why I did that to myself, to put this boring C all the time. Anyway. Okay, so that is the reason I copy and pasted there, but then I didn't know that I have to suffer later, yes? Putting all these damn C's. Okay, so that's it. So if you don't recall this, then there is no way for you to solve it. So remember, these exercises, I have fine-tuned them so that you learn something. Okay, but what about number 2? It seems that I am violating the rule a little bit, because of course I have a fraction, so this is not working for all fractions. Be careful, there is no quotient rule there. It's a very particular form of fraction. But then it seems that this method is not working, yes? Because the denominator is x to the power of 3 plus 1. What is its derivative? 3x squared. But what do I have in the numerator? X squared. Either you should give up or you need to find a way. So do you have any suggestion here?
Maybe you could multiply by 3 over 3.
Yes, thank you. So what we do, we just write 1 over 3, and then I multiply by 3 to compensate that. Now, hopefully you agree I didn't change anything. But now I give the rule of u to this guy. What this will be then? EU prime. But of course, this 1 over 3 is not disturbing because that's just a multiplicative constant. So that's the same rule. So if I ask you what is capital F here, what is your answer? Is 1/3 what? ln of u, which is x to the power of 3 plus 1. To be honest here, I have to put the absolute value. In the previous one, I really didn't bother to put absolute value even. Why?
Because it's always positive.
Positive. X squared plus 1 is always positive. Because x cubed plus 1 is not guaranteed to be positive all the time. That's it. Yes? And the last example for today is number 3. Do you remember when I was writing a table of formulas, I talked about primitive function for sine, for cosine, but we didn't talk about tangent. This tangent is somehow later comes in your book. That's why I want you to do that. But how can I do that, by the way? I think you remember the trick now. So what should I do? Is tangent a fraction? Yes. So it is what? Sine x over cosine x. But if I give the role of u to this guy, okay, what will happen for the u prime?
Minus.
It becomes minus. But now you learn the trick, as Aaron mentioned. Yes, what we do?
Multiply by.
Yes, we multiply by minus sign and another minus sign. Yes, I put minus 1, and then I put minus sine x here, and then cosine x here. Do you agree? That's the same thing. But now, if I give the role of u to this, do you agree with me that this becomes exactly u prime? This minus sign is just a minor problem here. It's minus 1, so I can pull it out. So what is a primitive function? F of x is equal to, I have a minus sign, which is a minus 1, and then ln of cosine, which in this case, absolute value is indeed necessary, yes? That's the primitive function. Cosine can be sometimes positive, sometimes negative. I told you before that this is the correct way of writing because we don't know if x is positive or negative. Okay. Any questions? So here we actually complete finding primitive functions, so you have enough experience.
Can you try with the ones that are not defined, like with the e to the power of x squared? You showed us earlier. If you do it with this fraction, you understand what I mean?
No. How should I understand?
E to the x to the 2.
No, you're mixing two things.
Yes.
One thing is e to the power of x squared, which I told you there are no primitive functions for them. And then how is that related suddenly to this problem? I don't
No, I
understand.
was thinking of exponential functions and fractions. Perhaps there are some problems.
No, there are, but we are not supposed to study it in math for. Any questions? For example, let me, just Hussein said, let us not break his heart, you know. So, okay, what do you think about this function? F of x is equal to 5 e to power 3x over e to power 3x negative square root of 2. Is there any way to find a primitive function to this guy?
Well, the derivative e to 3x is really e to 3x.
Yeah, so that's exactly the same idea, yes? But you have to fine-tune it a little bit, yes? So if I want to give the role of u directly to this one, so what's the derivative of u? Is 3 e to power 3x.
Yes.
Unfortunately, I don't know, this 5 has made its way here. We want to get rid of it because we need 3. But that is let us call it Aaron's method, yes? So what we do, we just put 3 e to power 3x and then divide it by what? E to power 3x minus the square root of 2. But the price that I have to pay to compensate for that 3 is to? Multiply by? 5 over 3, yes, because I want to bring it back. Yes, you cannot get rid of this 5. You have to live with it, yes? Yes, it's like your genes, you know, it's attached to you. So you need to train them to use them properly, but that's you, yes? So this is why it works. Now, can I give the role of u to this guy? And then this becomes what? U prime, and then 5 over 3, who cares? That's just a constant. So it becomes 5 over 3 ln of e to the power of 3x minus the square root of 2, absolute value closed and C. Yes?
That was a nice question.
Yeah? That is for your heart, you know. Okay, so now let us do something for my heart, okay? So f of x is equal to, I don't know, So let me write, let us test your understanding, by the way. How can you imagine now? Okay, this is the function. Give me the primitive function now. Yes?
When you derive the denominator, can't you use the product rule?
No. Which product rule? No, be careful, because if you want to use there is no product rule for primitive function.
No, I know, but you need to know what the derivative of x ln x is.
No,
Then you can
1
use the
over.
product rule.
No, it doesn't help you. Even if you know what's the primitive function for x ln of x, which you don't know, assume that you know. But it has nothing to do with the primitive function of 1 over that thing.
Okay.
So even if you succeed, there is a way to find the primitive function for x ln of x. That's called integration by parts. You will study that later. But even if I give you that answer ready-made for you, you cannot find a primitive function for 1 over that thing. So do you see that's the same problem? Because you insist your brain, I want to solve something in your brain. In your brain, you want to keep this u, yes? And then you say that, okay, the derivative of x ln of x is not 1. It's a very more complicated thing. So then what do I do? But you have to be a little bit creative, okay? I will write it as this one. Yes? Is that right? That's the same thing. Of course, if you are not good in algebra, might be you will not see this. But everyone now, do you agree that what I have written is exactly the same expression? Yes or no?
Yes.
Okay. Because 1 over x divided by ln of x is just 1 over x times ln of x, yes? Yes or no?
Yep.
Okay. And then do you think that this trick is working now?
Yes.
Because now if I give the role of u to this one, what is this one? U prime. And then what the answer is? ln of x.
Plus c.
ln of absolute value of ln of x plus c. Yes? Okay, so,
So wait,
yes?
this was very complicated. Would it be like if it was u derivative of u and another inside another one? Would it be ln of ln of ln of ln of x?
So if you ask these questions, I will particularly give you these questions in the exam, okay? So I bring you a lot of elements in your questions, okay? And then you have to solve
But
it.
do you know how it look like? Would
Yes?
it be like x ln of x over 1, or how would it be? How would
So I don't know, you have to make it, so just tell me what you want to say. Sometimes it is not working, you know?
yes.
Okay, but that is, I mean, these are the level that you really can do that, of course. But this trick you need to know. If a teacher doesn't talk about this trick to you, might be it is not that easy to detect it on your own. Yes?